Hello everyone. In this session, I will be explaining you a DDA algorithm, which is also known as a digital differential algorithm, digital differential analyzer algorithm, and this is the part of computer aided design. So to generate any line on the screen, over the screen, there are two basic algorithms are getting used. First is Bresenham's algorithm. For that purpose, you can see my another recorded video for the Bresenham's example, and in this video I'll be explaining the DDA algorithm, how this method works. So the question is that find the raster locations by using DDA algorithm between the coordinates. Which coordinates? 1 1 and the another is 5 and 4. So they are telling that we need to find intermediate locations of the points by using DDA algorithm. So I am listing down the data. The given data is A, that is here 1 1, and B 5 4. Respectively, x1 will be the 1, y1 will be the 1, x2 will be 5, and y2 will be 4. Okay, so the step 1 is to calculate the delta x. So first what we'll do, you have to calculate the delta x. Delta x is equal to x2 minus x1. So placing those values, x2 minus x1, 5 minus 1 is equal to 4. Similarly, delta y, y2 minus y1, 4 minus 1 is equal to 3. So this will be the step 1 for me. In next step, I will calculate the slope, which is called as a m. To calculate the slope, the equation for slope is delta y by delta x. So delta y is 3 and delta x 4. So 3 divided by 4 will give me the 0.75. So now this value is very important for me. You can see that this value is less than 1. Now in DDA algorithm there are two cases, if m is greater than 1 or less than 1. So first let me tell you that if in another numerical you are getting greater than 1 or in another numerical you are getting less than 1, then what? If m is less than 1, then this equation is preferred. So in x value you have to add 1 always, and in y value you have to add the m, which is this. If inverse, if m value is greater than 1, then what you have to do, you have to do in x value addition of 1 by m, and in y value you will add 1 always. Okay, so now here in this our numerical we are getting 0.75. So I will suggest first that pause this video and write down this equation with you. It will be very useful in next numericals also. Okay, so right now 0.75, which is less than 1, so we will use this equation. What are the values are there? Xk plus 1, yk plus m. So step 3, we will prepare one table. In table what you have to do, calculation of x, calculation of y, x and y coordinates. Now you have noticed in first what you have to do, you have to put the initial points. So initial points are 1 and 1. So I'll place these points here 1 1. So x and y will be the 1. Now the next important step is that according to this equation you have to follow. So next x will be the xk plus 1. So previous 1 plus 1 will be the next k. So 1 plus 1 is equal to 2, and y will be yk plus m. So yk is the previous value. So 1 plus m, which is a 0.75 what we have obtained. So 1 plus 0.75 will be the 1.75. So that will be the 1.75. Now the rule is that if the value is greater than 0.5, so if it is value is greater than 1.50, then it will be counted as a 2. If its value is less than 1.50, then I will count as a 1. So I have to put a round of values here only. So keep it in mind, if value is greater than 0.5, then I will increase 1, and value is less than 0.5, then I will keep as it is, whatever value is there. Okay, so now I am getting here a 2.5 and here I am getting a, okay. Now next step, again xk plus 1. So the previous value 2 plus 1, so 2 plus 1 3 right here, Now here yk plus m, so previous yk was 1.75 plus m 0.75, so value is 2.5. Now as per rule that if it is less than 2.5 or equal to 2.5, then the value remains same, so it will be the 2.5 will be converted to the 2, and 2 plus 1 will be 3. Next step, here 2 plus 1 is 3, so 3 plus 1, okay, so it will be the 4, and here 2.5 plus 0.75, which is the value of m, is equal to 3.25. Now again 3.25 is less than 3.5, so it will be the round of value 3, so I will write a round of value as a 3 here. Now here again 4 plus 1, and this 3.25 plus 0.75 is equal to 4, so 4 plus 1 is equal to 5, which is x value, and 3.25 plus 0.75 will be the 4, so this is the value of y, so 4. So you have noticed that we have reached to the our end point, which was required 5 and 4. So these are the obtained intermediate points using the DDA algorithm. So point 1, point 2, point 3, point 4 and point 5. So this is the one case where the answer of m came less than 1. If m is greater than 1, then you have to use this equation simply, nothing else. So you can practice it again and again, and then you can make a mastery in it. Okay, so in next session we will bring something new topic. Till that, goodbye.